friends, we're going to deal with chapter 13 and 14. They're really technically both 13, but we split them up. So chapter 13 was triangles. So let's get into it. Keep in mind that when you have right triangles, you use SOHCAHTOA. And that when you need to find angles, you need to use sine inverse, cosine inverse, and tangent inverse if you're ever finding an angle. This is for finding sides. Okay, so solving for x, here's my angle. If I shoot straight across from the angle, that's the opposite side. Straight across from the 90, that's the hypotenuse. So since those are the two pieces that I have or looking for, O and H means I'm going to have to use sine. So the sine of 31 degrees is going to equal the opposite over hypotenuse. And then to solve for x, I would just multiply 15 up. So make sure your calculator is in degree mode or you're going to get all kinds of wonky McDonkey answers. So I'm going to do the same thing. I am in degree mode. Okay, so 15 times the sine of 31, I get 7.7-ish. And keep in mind it would be multiple choice. So again, across from this is the hypotenuse, which is not marked. Across from the angle that's given is the opposite. And that means the 7 must be the adjacent. It's kind of like the leftover side. So since the adjacent and the opposite are involved, that's going to be TOA. So tangent of 48 equals opposite over adjacent. So when the number's on the bottom, I just multiply it up. So 7 tan 48 gives me 7.77 as a length. All right. Here's my angle. So the side across from it is the opposite. Side across from the 90 is the hypotenuse, and the other side's going to be adjacent. So this is being asked about. This is given. So adjacent and hypotenuse means I'm using cosine. And so cosine of 68 equals adjacent over hypotenuse. So now this time the x is on the bottom. You can put it over 1 and do cross multiplying, or I kind of use a shortcut and I swap them out. I can put the x here, and then the cosine 68 will go to the bottom. So when the x is on the bottom, you can swap out the trig function and the x. And then on my calculator, I just do 22 divided by the cosine of 68, and I end up with a length of 58.7-ish. And here's my angle. Straight across from that is opposite. Here's my 90. Straight across from that's hypotenuse. This side is the leftover, but I also don't know or need to know anything about that side. It's blank. So I'm only interested in opposite and hypotenuse. Opposite and hypotenuse means I have to use sine. So the sine of 39 degrees is equal to the opposite over hypotenuse. And with that x in the bottom, I can just swap that out. And then I'll take the 11 divided by the sine of 39. So that's turning out to be 17.47 or 17.5-ish. Okay, so coterminal. This is actually from chapter 14 technically, so is this. So if you're looking at like your notes, you're not going to find it in 13. Coterminal means that you are taking your angle and adding or subtracting trips around the circle, which might be 360 or it might be 2 pi, depending on if it's radi or degrees. So like with 211, if I add 360 to it, I get something wrong because I typed in the wrong number. I get 571. So that means this one is coterminal. What if I add 360 again? Because you can keep doing this any number of times. So I'm going to add 360 again. I get 931. So that's coterminal. Coterminal has to be something you get by adding or subtracting 360 to the 211. What if I take 211 and subtract 360? Then I get negative 149. So all of those are coterminal, meaning this is the one that is not. This is the same concept, but in radians. I always told my class, if the bottom's a 3 and you're trying to do 2 pi, you need the top to be twice as big because 6 over 3 would reduce. So I'm going to be adding or subtracting 6 to the top because when you have common denominator of 3 on the bottom, you don't have to worry about it. That's why all the answers have 3s. So I have 7 pi plus or minus 6 pi over 3. So like 7 plus 6 would be 13 pi over 3. 7 minus 6 would be 1 pi over 3. So these all are coterminal. What if since these are negative, what if I took my 1 pi over 3 that I got by taking 7 pi over 3 and subtracting 1 trip around the circle? What if I subtracted another trip around the circle from that? I'd get negative 5 pi over 3. So this is coterminal. I never got that because that's something I can't get by adding or subtracting trips around the circle. So that's one that is not coterminal. Here I'm probably going to need a picture. A tree is 13 feet high and its shadow is 30 feet long. What is the angle of elevation to the top of the tree? Okay, first of all, we're looking for an angle, so you should be thinking inverse. An angle of elevation means up from the ground, so they're asking about this angle down here. So when I look at that, I think, well, across from the angle is opposite, and across from the 90s edge hypotenuse, and then that would make the 30 the adjacent side. So this question involves opposite and adjacent, and if you have opposite and adjacent, you're dealing with tangent. But I'm not trying to find a side. I'm trying to find an angle. See, now the choking is going to begin. So I have to do tangent inverse and tell my calculator what the opposite over adjacent is. And when I do tan inverse of that, I get about 23.43, and that is B. A wire is tied from the top of a tower to the top of another tower. Taller tower. So from this to this. Okay. The angle of depression from the top of the taller tower to the top of the shorter tower. Okay. Angle of depression means down. So that makes this 37 degrees. But this is the triangle that I'm actually dealing with that has this part. So if this is 37 on the outside, this corner, then this corner in here is also 37 because of that alternating interior angles from geometry. So if you have like a Z shape, the two corners of the Z will be the same. So essentially I have a triangle like this, where this is 37 degrees. And it says, if the wire is 100 feet long, so that's this thing, find the distance between the towers. So that's this. So here I am looking for a distance, not an angle. So I'll use regular SOHCAHTOA. If this is my angle, this is opposite across from the 90s hypotenuse, and that makes this adjacent. So I have adjacent and hypotenuse involved, and that's going to mean using cosine. So the cosine of 37 is going to be my adjacent, which I don't know, over my hypotenuse, and I can end up multiplying the 100 to both sides. And when I do that, I end up with about 79.86-ish feet. So you only use inverse when you're looking for an angle. All right, so now I think these hints are wrong if I remember correctly, so let's ignore the hints. These are no longer right triangles, and when you do not have a right triangle anymore, you have to use law of sines and cosines, and you absolutely need those written onto your paper. The law of sines you can only use if you know an opposite angle and side. So what I always do is, like, these are D, E, F. That was weird. And then the sides would be little d, E, F. What do I know? I know that side D is 14, angle D is 43. So this is actually a law of sines problem because I have a pair. Then I know that angle E is 27. I'm supposed to find side F. Keep in mind that if you know two of the three angles, you can find the third one by subtraction. They have to add up to 180. So 180 minus the two that were given will tell me that third angle. So that third angle is going to be 110. And I need that because when you're using the law of sines, you need to know three of the four things, because you're going to have the sine of one angle over the side across from it, and then set that equal to the sine of the other angle over the side across from it. And you're going to cross multiply essentially. So 14 times sine 110 equals F times sine 43. Dividing out the sine 43. Just be careful on your calculator. Your calculator is going to open up a parenthesis here. Make sure you shut her down. So try it on your calculator. Go 14, sine 110, and then close that parenthesis. If you don't, you'll get the wrong answer. And then divide by the sine of 43. And when you do, you should get 19.3-ish. Okay. In the next one, if you set this up, it says we have an ABC. So A, B, C, little a, little b, little c. I know this, and I know this. And I'm, whoopsies, that's not right. And they're asking me this. I cannot use the law of sines because I do not have enough information. I don't have a matching pair. So I have to use law of cosines. And law of cosines, I'm going to take the side that I'm trying to find squared out front, and then each of the other sides squared. So 7 squared plus 12 squared minus 2 times each of those. And if you're looking at the written answer key, she forgot to put the 7 in there. And then the cosine of the angle, keeping in mind that these have to be the same. So since this was side A, this has to be angle A. Okay. So I'm just going to do all of this on my calculator in this case because I know all the numbers on the right. And when I do that, I end up with A squared equals, I'm not sure what, I think it was 296. And then when you square root that, I get 17.2, which is the answer that you would want for that. So the answer key on that one appears to be wrong. Okay, then the other thing we learned was area. And we learned a couple different formulas, and you have to, depends on what you know. So like here, I know 2 sides and the angle between them, side angle, side. Our formula for area there was 1/2 times one of the sides times the other side times the sine of the angle in between them. And this angle is indeed in between them. So I'm just going to have 1/2, 15, 13, and then the sine of the angle between them. So 1/2 times 15 times 13 times sine 30 is going to put me at 48.75. And so then this is going to be, wow, that's pretty tricky. That's going to be my best option. Look at this one's pretty close. So make sure you're rounding off properly. Here, the area of all 3 sides, we learned a formula for that. So on your cheat sheet, it would be really smart to have which formula goes with what information given. So this one's all 3 sides. And our formula for that was area equals big fat square root, and then this business, which is not very helpful if you don't know what any of that means. A, B, and C are the sides of your triangle, but S is what we call the semi-perimeter, which you get by adding up the sides of the triangle and dividing that in half. So in this problem, my semi-perimeter is going to be 11 plus 14 plus another 14, all divided in half. So use parentheses to make sure you get the whole top. When you divide that in half, you get 19.5. So I'm going to end up with a square root of 19.5, and then I do 19.5 minus each of the triangle side lengths. Doesn't make a difference what order you do, so whatever. Okay, so that's just a lot of stuff to put into your calculator, but this all comes out when you use the square root at the end with to be 70.809. So 70.8 is your best bet. So that is D. So I am going to stop there, I guess. No, I'm not. I'm just going to go ahead with 14 since it's kind of the same one. This one is going to go to unit circle and such. So you would use your unit circle when you need to. Converting to radians, if you have degrees, you use pi over 180, and you end up taking this fraction and reducing it on your calculator and leaving your answer as a fraction of pi. When you start with radians, you use 180 over pi. Usually the pi's cancel and you proceed. So if I have to convert 290, that's degrees, so that means my degree goes on the bottom of my conversion. I go to my calculator, 290 over 180. I reduce that fraction, and I get 29 over something I can't read, 18. And that's fractions of pi because I never got rid of the pi. So that's going to be choice B. In this one, 25 pi over 12 is radians. So that means that the radians part goes on the bottom of my conversion. The pi's cancel. And then I just bust out ye old calculator and make my way through the math that's left. 25 times 180 divided by 12. And I got 375. So those conversions, you definitely, like, as you go through here, like, these are the verbs I have to be able to do. Find the area of the triangle using SAS. Find the area of the triangle using SSS. Convert to radians, convert to degrees. That's 100% what you're going to have to do. Now we did solving. Solving is going to be solving like normal, where we're trying to get this part alone. So I'm going to start by adding 3. Then I'm going to divide by 4, just trying to get that part alone. So now I have sine of theta squared equals 3 over 4. Here's the part where a lot of people went wrong. When you introduce the square root, you have to remember to add plus minus into the problem. Here the square and the sine cancel, so I just have sine theta left. Over here, let's remember, this could separate out for top and bottom. The top doesn't have a square root, but the square root of 4 is a 2. So now you're going to go to the unit circle and figure out where is the sign, either positive or negative, root 3 over 2, and sine is the y value. So you're going to look for the y value on, I lost my place. You're going to look for the y value and see where it has either positive or negative square root 3 over 2. And when I look for that, I find like here, 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 and here, which is at 60 degrees, 120 degrees, at the bottom 240 degrees, and 300 degrees. Okay, solving this one, 2 cosine theta plus 1 equals 0. This is the part you're trying to get alone, so treat it like algebra 1. Then divide by 2. So now I'm going to the unit circle to figure out where does the cosine have a value of negative half, and cosine is x. So where is the x? Negative 1/2, here and here. So you look on your unit circle and figure out where does that happen. And that is going to happen at, looks like 120 and 240. So then that matches with B. Okay. Use your unit circle to evaluate. All this means is to go here and find this. So go to 210 on your unit circle, which is down here, and then sine is y. So find the y value of that coordinate. And when you look on the unit circle, you should see negative root 3 over 2, negative 1/2. So negative 1/2 is going to be your answer for that one. 7 pi over 6. Okay, that one you can find 7 pi over 6, keeping in mind that it's going to be over here because this pi would be 6 over 6. So 7 pi over 6 is here. It's actually in the same spot as the previous one, but now they want the cosine, which is the x. And if you look at the coordinates of that spot, your x is going to be negative root 3 over 2. So friends, that's the ends of 13 and 14, and I believe that's all the review videos. Mr. Bunting made review videos from here on, so watch whatever sections you need to watch to be successful. Bye!